and then there's a little other distance, different distance that's done in an aligned dimensioning fashion. See the included handouts for dimensional data concerning the fan and motor. Select a single chain operating under a smooth load condition. Calculate the number of teeth needed for the driver and driven sprockets. Also calculate the length of the chain needed. Now, the fan is driven at 2,000 RPM. The motor is 1760. Which shaft operates faster?
The fan shaft.
The fan shaft does. Which shaft gets the smaller number of teeth?
The fan shaft.
The fan shaft will. This is out of the ordinary from most design situations where the motor is running much faster than the piece of equipment is. So we're taking the motor and we're increasing the speed for the fan to get it up to its proper operating speed. So the small sprocket goes on the fan shaft. Other than that, it's just straightforward stuff. So here's the design information set up for you. There's no service factor. The design horsepower is 10. There's no adjustment to that. So you've got the charts to work off of. Now, originally when I had this project going, I had everybody do the drawings itself based on the dimensional data. That's not an uncommon thing for you to do as a drafter, is to get a catalog of a piece of equipment and make a reasonably accurate drawing of the piece of equipment and the fan to take stress off your life and probably stress off my life. I am going to give you, once again, the drawing of the assembly of the fan and the motor, and you're going to fill in the blanks, calculating the number of teeth in the sprockets, adding those to a bill of material, completing the bill of material based on certain assumptions that we've made concerning all that. I'm going to go through and show you what you would have worked with and what you might work with as a drafter, and how kind of complicated it can kind of be sometimes, and I'm just trying to make your life easier. You're welcome. All right, so there's a particular model number and fan size number for the project. We would have made an assumption that the mounting bolts for the fan were already in the concrete floor where this fan was going to be situated. There was dimensional data to do that. So I could have taken the dimensional data from the fan information, made an installation drawing, and marked out where the bolts were supposed to be. So we make that assumption. The 10 horsepower electric motor is a certain brand and certain model number, and it has a certain frame associated with that. There was also a motor base that went along with it to mount the motor on, and we could assume that there would be 7/16 14 UNC mounting bolts embedded in the floor for the motor slide base. Once you determined what the location of the motor, where the motor was, and then a 3/8 24 UNF bolt for the motor mount bolts on the motor slide base also came with the motor base. That was information that was included in the catalog. So your task is then to complete the assembly drawing for installation of the motor, of the fan and motor. Dimensions needed would be those necessary to position the fan and motor correctly. Indicate all necessary items needed in a bill of material. Title is going to be Centrifugal Fan Chain Drive Assembly. The text type is 5/32 of an inch. Standard for this class for this term. Drawing number is going to be KIN 255-4. Text type for the drawing number is 1/8 inch. Plot the drawing at a scale of 1 inch equals 1 foot, which is a scale factor of 12. Now we're back to a discussion of, do I want to do all of this in model space? Or do I want to take the drawing that's existing that you'll work from, use that, and do insertion of the title block in layout space? And I'm leaving the decision up to you. And I've gone through that discussion, and it should be pretty much the same except for the scale factor. Scale factor on the first one was 4. This scale factor is 12. Diameter of the item balloons is 5/16 of an inch. 0.3125 multiplied by 12 gives you the diameter of the item balloons that would exist on the drawing in order for them to plot out at 5/16 of an inch height. Height of the text in the bill of material is 0.1. You multiply that by 12. You actually get a height of 1.2 if you put the title block into model space and fill the bill of material in model space. If you insert the title block in layout space and fill it in layout space, the height of the text is 0.1. Some people like to do it that way. Other people want to do the scale factor. You need to be able to do it both ways. You might end up working in a company that doesn't have AutoCAD 2017, soon to be probably 2018. You may be working with AutoCAD 2008, and it doesn't do annotative and it doesn't do all that kind of stuff. You need to be ready to do some scale factoring. Plus, if you're looking at particular sizes and distances in model space, you have to then multiply that by your scale factor of your drawing scale. Otherwise, it's going to be little teeny tiny, offsets or something. So you have to be aware of all that. That's why we're doing bigger drawings in this class. All right. There is a PDF of what the drawing will look like. That's down at the bottom where it says chain drive assembly and a PDF symbol. I'm only going to show you these because this is what you would have worked with or might work with as a drafter. They're for your information. Your information, your information, your information. These have already been drawn as an AutoCAD drawing that I'm going to have to make available to you. I didn't put it in there. I will get that in. Okay, so if I actually looked at the information on a chain on the fan, I've downloaded that, put that in there, and it ends up looking like this. Catalog page. Yep. Looks like this. So there's different configurations, which give me different. So I've got a lot of letters. I would be using the 2450. There's a shaft diameter. There's a keyway in this shaft that's 3/8 by 3/16. There's a dimension A. So I would have to take this dimension A, and I'd have to do a drawing based off of that 21 and 2.5 inches to be able to draw the drawing. I'd have to look at the E. It didn't really tell me how big the little angle iron brackets were, so I'd have to kind of scale some of that drawing or call up a salesman and ask him, hey, what's the size of this angle bracket that I'm maybe using in this drawing? That's what made this particular project somewhat complicated, and everybody kind of went this and took a lot of extra time and frustration and anxiety and angst. So it's been done. But this is what you possibly would have to work with on that. There was also some basic information on the frame of the drawing. It was a 215T frame. So I've got dimensions. Horsepower was 10. I got a dimension for A. This is what I would have to use to try to draw as reasonable a facsimile of the motor as possible. That I'd have very limited information in here. I'd have a few basic dimensions. I'd have to do the best I could to come up with a drawing that would look like. Or I go to Baldor's website and I see if they have a 3D model of a motor, which they did. And on their website, there was an actual AutoCAD drawing that was downloadable. So I went in and I'm going, well, there's an awful lot of detail in this end view here that exists in my drawing. And by the time I add some line weights into here, almost all that detail is just going to basically disappear. It's going to be this big blob of black ink. So I went in there and I took out a lot of this extraneous detail and used just the basics of it for the drawing. And I kind of use this to try to come up with a top view. Here's your shaft diameter, 1 3/8 of an inch. So I've got dimensional data that I could use for that. And there was also a drawing of the motor base with dimensions. Again, it's something that you'd have to work off of, potentially. So again, I've got a 215 frame, and I've got like the AL dimension for the 215. I'd have to come in here and I'd have to make that 15 inches. I've got AO, which is 5 1/4, so I'm using those dimensions. This little illustration to make an AutoCAD drawing of my base to put the motor on and situate it. Here, right here, this actually the D dimension up here, that's a little mounting bolt that came along. So the D dimension mounting bolt diameter was 3/8 of an inch, and I made it a unified national fine because this is a motor that has vibration, and the base is going to have a certain amount of vibration. I would put a fine thread in there. It has more threads to the inch, which theoretically has more holding power, which theoretically the nuts, even with lock washers, wouldn't have as much of an opportunity to loosen up and back out. So that's why I picked the 3/8, I think it was 24 UNF. That was the reasoning for that. And then there was information on the frame. Which gets you to the point of getting a drawing that ends up looking like this. I have an example up here on the board. You have the PDF of it. The dimensions, since this is already kind of established, I went ahead and put the dimensions on there. There's a dimension from the end of the shaft to where the hub would go on the sprockets, theoretically being that this is going to line up so that you keep that chain not being skewed and wearing out prematurely. Identifying, so you can see that even with taking out a lot of that little detail, this kind of ends up looking like sort of a black area, but it kind of, I'd use really light line weights on it so you can come up and take a look at the detail. I have left blanks in here for you to determine how many teeth and what the size of the chain is going to be. All the rest of the information is pretty well established in there, so you shouldn't have that much trouble. And you've got a lot of time to work on this to get it in and get me a plot. Part of the assignment is to do a plot, if at all possible, but there's a few that are having struggle getting plots to me. And so that's the assignment. I just haven't put the drawing up there available for you yet. Questions? Too much information for questions yet. Yes, Red?
So you said the 4 PDFs in the content section are for like future reference and personal edification that we wouldn't need in this particular project?
Correct.
The 2 DWG files above those, are those also for future edification, or are those something we're using?
Let's see, let me go back here.
It's like McMaster
those were drawings that you would have used to create the drawing. This fan shaft bearing was in the drawing, and I downloaded it off of McMaster Car, and the electric motor was that little sheet that I showed you up here.
Right.
If you were creating the drawing and you had to create the fan drawing and the motor base, that would have been what you would have used.
Okay, so that's kind of the same category as the 4 PDFs.
Yeah, basically all of these are for your information to go back and look at and wipe your brow and go, wow, I sure am glad I didn't have to do all that stuff.
I just keep doing them in a separate file.
Yeah.
That's all I just wanted to know.
I just didn't, somehow I just missed getting the actual drawing file in there for you. Which I'll have to go over to my office and do because I can't do it from in here.
So yeah, the actual drawing's missing.
Yeah, the actual drawing to work from. But you got calculations to work on anyway. You got an assignment in D2L to download It's only one calculation.
Yeah, assignment number 3, chain drive.
Assignment number 3,
calculation.
chain drive calculation. Yep. I'm sure there will be other questions that will come up.
See you Monday.
Assignment
Okay.
number 3.
I will stop this, and I'll get this eventually up